Okay, welcome to another video. I'm Lee. So in the previous two videos we've looked at solving simultaneous equations, and the way that we've been solving them is effectively using the substitution method. So I'll just give one very quick example. This is very similar to the kind of question that we've looked at in the previous two videos. So y is equal to 2x plus 3 and y is equal to 5x minus 3. So in this case here, y equals something, so you can set these to equal to each other. 2x plus 3 is equal to 5x minus 3. Here you can subtract 2x from both sides, so you will have 3 is equal to 5x subtract 2x is 3x. And then if we add 3 to both sides, we'll have 3x is equal to 3 plus 3, or 6. So 3x equals 6. I'll write that out in one line. So now we need to divide both sides by 3, and we'll get that x is 6 divided by 3, which is 2. And then once we have that, we can then substitute that into our first equation there. Y is equal to 2 lots of x, in this case our x is 2, plus 3. 4 plus 3 is 7, y is 7. So our coordinate that our two lines intersect is 2, 7, and then in the past I've shown you how you can substitute these values back into here, and if everything works out, then this is almost certainly the correct answer. Okay, well, sometimes you don't have y equals something, y equals something. Sometimes it's written a little bit differently. So this is another example question. Y equals 3x minus 1 and 2x plus 4y equals 10. So two fresh equations. Okay, well, we're going to substitute here. And what we're going to do is we're going to say, well, if y is equal to 3x minus 1, then this y here is 3x minus 1. So we're going to substitute this part here in for this y. And we're going to say that that will be 2x plus 4 lots of y, and y is 3x minus 1, equals 10. And then the next step then is to multiply out the bracket. So 4 times 3x is 12x. 4 times minus 1 is minus 4. Collect like terms, so here we have 14x. So here we've got to subtract 4, so we're going to add 4 on both sides. And we calculate that x is equal to 1. So then we can put this into our first equation. Y is equal to 3 lots of x, which in this case is 1, subtract 1. So y is equal to 3, subtract 1, 2. Y is equal to 2. Okay, so that is our coordinate, that's our result. You can then substitute this back into equation 2. So equation 2 is 2x plus 4y. And that should equal 10. So if we put our result for x and y in here, and we calculate this is 2 plus 8, which is 10. Well, that's what we expected. So yeah, that's almost certainly the correct answer. So let's have another go at one of these questions. 6x plus y equals 4. 5x plus 2y is equal to 1. And I'm going to invite you here to pause the video for a second so that you can try and use the same sort of technique here as what we've used here, but there is one extra step. So I'm just going to pause for a second there. If you're struggling to work out here, you know, this is a little bit different to this question, it's because you need to rearrange this equation so that you have y equals something. So, excuse me, if you know you need a second now to work that out, then go ahead, pause the video. If not, to get y on its own, we simply have to get rid of the 6x, so we subtract 6x off both sides. So then the right hand side will be 4 subtract 6x. And now you have two equations which is very similar to this example here, just that the numbers are different. So have a go, pause the video. It should only take you 2 or 3 minutes to go through that example. Okay, so now we'll work through the example together. So what we do here, very similar to this example, we take what y is equal to there and we substitute it in for that y right there. So we have 5x plus 2 lots of y is 4 minus 6x, and that all equals 1. So now we multiply out the bracket. 2 times 4 is 8, 2 times minus 6 is minus 12. It's equal to 1. Now if we collect the like terms on this side, we combine the x's. 5x minus 12x is minus 7x plus 8 is equal to 1. If quite a lot of people make a mistake with, when negatives are involved. If you're struggling, what you can do here is you can change these two signs and you can say it's 12 positive 12x subtract 5x. So 12 subtract 5 is 7, and then you just have to put the minus in front of the 7 then. So then here we can get rid of the positive 8 by subtracting 8 from both sides. Minus 7x is equal to 1 minus 8, it's minus 7, times both sides here by minus 1, so we have 7x equals 7, x is equal to 1. Alternatively here, you could times everything here by minus 1 and have 7x minus 8 equals minus 1, and then plus 8 on both sides. Follow that through, you'll get x equals 1. Different people will naturally solve things in a slightly different way, so I'll try to show multiple approaches in a lot of examples that I give. So once you've worked out this value of x here, you can substitute it into our first equation. 6 lots of 1 plus y is equal to 4, so that's 6 plus y equals 4. Subtract 6 off both sides, y is minus 2. And then once you have both of these solutions, what you can do then is substitute these into this equation here. So 5 lots of x, which is 1, plus 2 lots of y, which is negative 2. So that's 5 minus 4, which is 1. Is that what we had up there? Yes, it is. Okay, so that is almost certainly the correct answer. And I think that's where I'll leave this video for now. Hopefully this has been useful to you. So please comment down below if you'd like to see more examples like this, or if you have a request for me to look at a different topic. Or alternatively, if you actually have a question like this that you've came across on a paper and you've attempted it and maybe you've not got it quite right, if you'd like to send me your response to that question and I'll mark it for you, as long as you allow me to share it with the world. Yeah, that's everything I've got right now. I'll try and get another video uploaded. It's 20 past 10 for me now. I'll try get another video uploaded in about 3 or 4 hours. Probably another video on simultaneous equations, but we'll look at the elimination method rather than substitution. But thank you very much for watching, and I'll see you next time.